This is an introductory program on the XJ-6 engine management system. The program is divided into sections, at the end of which you'll be shown a menu. From this you can decide the order in which to work through the program, although the order in which it's presented is advisable. We'll be looking at the fuel supply and return system, components of the engine management system, how it operates and correct maintenance procedures. We also include a reference section summarizing each part of the program. In this section, we'll be looking at the fuel supply and return system. The fuel tank is located behind the back seat. How would you gain access to the tank? Yes, by removing the spare wheel, jack and trim, we can see it clearly from the boot. Underneath the tank there are two connections. The larger one connects to the fuel supply pipe and the smaller one to the fuel return pipe. These pipes are secured by metal clips which fit into grooves on the connections. The pipes are removed simply by twisting the clips through 90 degrees and pulling the connections apart. Looking at a sectioned end of the tank, at the top we see the coiled pipe evaporative loss system, the expansion tank, and below one of the two baffles which prevents fuel slosh. The other baffle is positioned at the other end of the tank. This is a section of the tank. Seen from the top, starting from right to left, are the expansion tank, the swirl pot, the drain plug with magnetic pickup. Positioned in the tank, the swirl pot plays an important role in the supply and return system. Fuel being fed to the system leaves through this connection, and fuel being returned to the tank enters here. All return fuel enters the swirl pot and is swirled anti-clockwise. It then passes through the filter and into the outlet connection. Under low engine demand, excess fuel will overflow from the swirl pot back into the main tank. The swirl pot ensures a head of fuel during acceleration or cornering, or when the fuel level in the tank is low. Underneath the car we can see two external connections which link the tank to the fuel supply and return system. Fuel leaving the tank is then fed along a pipe to the fuel pump. Which tank connection supplies fuel to the fuel pump? No, yes, the large one supplies fuel to the return. The smaller is the larger fuel returning from the fuel supply pipe, which runs to the fuel pump. The fuel pump is located at the rear of the car on the rear axle subframe. We've removed its outer casing so that you can see its internal components. Inside the sleeve are the permanent magnets, part of the motor which drives the pump. The armature with the commutator, the windings, and the roller cell pump. Next, the electrical connections and brushes which contact the commutator, which in turn drives the motor. The external electrical connections and the one-way valve. The roller cell pump is driven by the motor. Fuel is drawn into the cell and then trapped. Centrifugal force pushes 5 rollers outwards, forcing the fuel out to the pressure side of the pump. As a safety measure, both a non-return and a pressure relief valve are an integral part of the pump. One of these valves prevents a build-up of excess pressure in the fuel line should there be a restriction in the line. The other valve maintains a primed fuel system when the pump isn't running. Which description fits each valve? Yes, the non-return valve maintains a primed fuel system when the pump isn't running. The pressure relief valve prevents a build-up of excess pressure if there's a restriction in the fuel line, and it allows existing fuel within the pump to be recycled at a high pressure. The pump itself is always completely full of fuel, although it never contains an ignitable mixture. Is that because... Yes, it's because the pump is completely full of fuel, that there's no room for oxygen, so the mixture can't ignite. The pump operates for approximately 1 second after the ignition is switched on, and only comes into operation again during engine cranking or running. Fuel from the pump travels along the supply line and enters the fuel filter positioned on the left-hand side of the car in front of the rear axle subframe. So would you say that the fuel would flow through the filter in this direction? No, yes, that's right. There's only one direction of flow through the filter, from the pressure feed side to the fuel rail. The fuel pipes we've seen have been covered either by black coil or a silver sleeve. Why is this necessary? Yes, it's important to keep the pipes cool. Heat could damage the rubber hose. There's also a shield between the fuel filter and exhaust for this reason. The insulation also protects the pipes from road debris. After the fuel is fed through the fuel filter, it travels the length of the car through the supply pipe and up into the engine compartment where it joins the fuel rail. Just before the supply pipe connects to the fuel rail, there's a saucer-shaped pulsation damper. As their name suggests, pulsation dampers absorb the fuel pulse as it flows through the system. They do this through a plastic diaphragm within the damper. After the fuel has passed through the damper along the supply pipe, it's fed into the fuel rail, which connects to 6 fuel injectors. These injectors fit directly into the inlet manifold. How are the injectors held into the inlet manifold? Yes, that's right. The injectors are clamped into place when the fuel rail is put into position. Within the system, the injectors are connected in parallel. Does this mean that they'll be activated individually or at the same time? Yes, that's right. Because they're connected in parallel, they must be activated at the same time. It is a simultaneous operation. Fuel not used by the injectors is fed along the fuel rail to the fuel pressure regulator. The function of the fuel pressure regulator is to maintain fuel pressure at a constant amount above manifold pressure and to counteract the manifold's vacuum below the injector nozzles. The fuel pressure regulator has 2 chambers. Its lower chamber has 2 connections. What are these connections to? Yes, there's a fuel inlet from the fuel rail and a fuel return line to the tank. A vacuum chamber above this is connected directly into the inlet manifold. Inside the pressure regulator, the spring-loaded diaphragm is held against the outlet duct, sealing it off. When fuel pressure on the diaphragm is sufficient to overcome spring pressure, the diaphragm distorts, compressing the spring and allowing excess fuel to escape via the outlet duct. When the outlet duct is exposed, it causes a reduction in fuel pressure and returns the diaphragm to its original position. The fuel pressure regulator will respond to both high inlet manifold conditions, when it reduces fuel pressure, and low inlet manifold conditions, when it increases fuel pressure. During one of these conditions, fuel pressure overcomes the spring, raising the diaphragm. During the other condition, the manifold pressure counteracts the force of the spring, assisting the diaphragm movement. Which description fits each of the conditions? Yes, low inlet manifold conditions, when accelerating, would raise the diaphragm, allowing excess fuel to return to the tank, whilst high inlet manifold conditions, when idling, would counteract the force of the spring. From the fuel pressure regulator, the fuel is fed through a second pulsation damper into the fuel return pipe, which travels along the length of the car and back into the fuel tank. That completes our overview of the Jaguar 3.6 fuel supply and return system. In this section, we'll look at the individual components of the engine management system, starting with the air filter. This is positioned between the wheel arch and the air mass meter. Its main purpose is to filter air entering the air mass meter. The air mass meter is located between the air filter and the throttle body. It gives a precise measurement of air mass and temperature to give fuel metering precision. This is the air mass meter showing the main air channel, the electrical connection, and the electronic module. Here we can see clearly its connection into the engine management system. Taking the air mass meter apart, we can see that above the main air channel is a bypass through which 2% of the air flows. How was airflow measured by previous airflow meters? Yes, a simple mechanical flap was used. This hot wire air mass meter, however, is far more accurate in measuring the temperature and volume of airflow. Housed within its bypass is a sensing wire and a compensating wire. The compensating wire has a small current passing through it. As air passes over the wire, its electrical resistance alters depending on the temperature of the air. It is by measuring this resistance that the air mass meter can assess the temperature of incoming air. The sensing wire, on the other hand, is heated to a known temperature above the compensating wire. Air flowing over the sensing wire has a cooling effect on it, which lowers its resistance. The greater the airflow, the greater the cooling effect. So, how will the sensing wire try to resume its known temperature above the compensating wire? Yes, that's right. The temperature by increasing its current flow, because it will resume its temperature above the compensating wire. The power consumed by increasing is related to the airflow. The wire will resume its temperature. A decrease in current, on the other hand, would only lower the temperature of the wire is related to the airflow. No, by decreasing the current, the temperature will drop, but by increasing the current flow, the wire will resume its temperature above the compensating wire. The power consumed is related to the airflow. From measuring the resistance in the compensating wire and the current flow in the sensing wire, the air mass meter is able to measure the temperature and volume of air entering the engine. The next component is the throttle potentiometer. Where's it mounted? Yes, the throttle potentiometer is located on the throttle spindle underneath the throttle housing onto the throttle butterfly. No, the throttle linkage is above the throttle housing. The throttle potentiometer is located on the throttle spindle below the throttle housing. The throttle potentiometer is a variable resistor which senses rotation of the throttle through this linkage and alters its resistance accordingly. To the left of the throttle housing is the supplementary air valve. The function of this valve is to provide extra air around the throttle butterfly in temperatures below -20 degrees centigrade. This is in addition to that provided by the idle speed controller. Why is there a need for extra air in these cold conditions? Yes, because more fuel is needed to drive the car, more air is needed to keep the correct fuel-air balance. This is the supplementary air valve's electrical connection, its electrical solenoid, and here is the bypass port that allows air to travel into the inlet manifold. The throttle elbow feeds air to the supplementary air valve and the idle speed controller. Where is the idle speed controller housing located? Yes, that's right. The idle speed controller housing is bolted onto the inlet manifold to the left of the throttle housing. As its name suggests, its function is to compensate for engine load at idle. So, would an increase in engine load cause idle speed to increase, decrease, or remain the same? No, yes, an increase in engine load, whether mechanical or electrical, will cause a decrease in idle speed. The idle speed controller will compensate for this by allowing extra air to bleed around the throttle butterfly. Here we have the idle speed controller housing with the idle speed controller. Inside, we can see the main bypass port through which the air travels. At the opposite end, we can see the bypass port for base idle adjustment, which can be made using this screw. All air fed into the housing enters at this point from the throttle elbow. Also within the housing is an overrun valve. Above the idle speed controller is the fuel rail connecting to the fuel injectors, which are also linked into the engine management system. How many injectors are there in the 3.6 engine system? No, yes, that's right. Remember, each of the 6 injectors feeds directly into the inlet manifold. And how are the injectors operated? No, yes, that's right. The injectors operate electromagnetically via a signal from the electronic control unit. Note that each injector has an electrical connection which links it to the engine management system. Each injector consists of a solenoid-operated valve. Electrical signals from the electronic control unit create a current flow in the solenoid windings, which in turn creates a magnetic field within the injector. This attracts a solenoid plunger away from a nozzle seat, which allows pressurized fuel to enter the inlet port. So how does the ECU actually control the amount of fuel that's delivered by the injectors? No, yes, the ECU controls the amount of fuel delivered by the injector by varying the injector on time. Pressure and voltage don't determine the amount of fuel delivered from the injector. Under normal engine conditions, injector openings will occur once per crankshaft revolution. How many times does this mean the injectors will open for every complete engine cycle? Yes,
No,
since one
injectors
complete
will
engine
open
cycle
twice
is made
per
up of
complete
2
engine
crankshaft
cycle.
revolutions,
This is because the
injectors
crankshaft
will
revolves
open
twice
twice.
during
This
this
is called
time,
half-flow
with one injector
injection
opening for each.
This is called half-flow injection. On the 3.6 engine, the crankshaft wheel is located on the crankshaft damper at the front of the engine. It's a toothed wheel split into 60 segments. However, the wheel has 3 missing teeth spaced at 120-degree intervals. How many teeth does the crankshaft wheel have in total?
No,
Yes, given that the wheel has
60
60 segments and 3 missing teeth,
the crankshaft
it has
has
57 teeth in total. The crankshaft sensor is located above the wheel on the engine timing cover. It is a permanent magnet, and it's through this that crankshaft rotation is sensed. As the crankshaft turns, the metal teeth rotate past the sensor. What effect will the alternate metal teeth and air gaps have on the sensor? Yes, the alternate metal teeth passing the sensor will affect the magnetic field.
They have an effect on the magnetic
This
field,
produces a
which
signal
can be used
to measure both crankshaft position and engine speed. The coolant temperature sensor is located in the thermostat housing. Which one of these is the coolant temperature sensor? The one on the left or the right?
Yes,
That's
the
the one on the
temperature
right.
gauge
The
sender
other
unit
is
for
the
the
temperature
instrument pack.
gauge
The
sender
coolant
unit
temperature
for the
sensor
instrument
is
pack.
the other one.
What exactly is coolant temperature?
No,
Yes, coolant temperature is the temperature of the engine
which is
measured by the heat of the water within the thermostat housing. No, ambient temperature is the temperature surrounding the car. Coolant temperature is the temperature of the engine measured by the heat of the water within the thermostat housing. Looking closely at the coolant temperature sensor, we can see its electrical connection. This is where the sensor is screwed into the thermostat housing. It's positioned in the housing so that this portion will sit directly in the coolant, sensing temperature. We've now looked at the components within the engine compartment which relate to the engine management system. Moving inside the car, we find the inertia switch housed in the footwell on the right-hand side. This is a safety component linked into the engine management system. At the top of the switch, there's a black button. In the event of a sudden impact, the switch is tripped, revealing a red sleeve. If we look at this cross-section, we can see how the switch operates. The inertia switch consists of a small ball bearing seated in a magnetic cup. Above the cup is a mechanism which operates a set of contacts. What will happen to the ball bearing in the event of a sudden impact? Yes, No,
and
the
it's
ball
this
bearing
that
is
trips the
thrown
switch
up
to reveal
touch
the red
lever
sleeve
above
and
the cup.
operates the
This
contacts.
operates the
This
contacts
sends a
and
signal to the ECU, which switches out the engine management system, which stops the engine.
To reset the inertia switch, simply push the black
button down.
The principal component of the engine management system is the electronic control unit, the ECU. This is also located inside the car below the glove compartment in front of the front passenger seat. The 3.6 engine has one engine management ECU, which has been developed by Lucas. It receives its information from the components we've seen around the engine, compares their inputs to the information stored in its memory, and from this controls both fuel injection and ignition drive. This completes our overview of the components within the engine management system. All components of the engine management system are linked into the ECU by these 2 connectors on the engine management harness. In general, connectors are used where it's necessary to link components into the main harness. Take a look at this round connector. It's a PM4 positive mate Mark IV type and is used for power. This half is the male and this is the female. This is a square connector. It's a PM HD, positive mate high density, and is used for signals. Which is the male half and which is the female half? No,
Yes,
it's
it's
always
inside
the pins of the connector half that gives it its description. Because it's important that the halves are securely joined, always ensure that the ramp lock mechanism is firmly in place. This will prevent the 2 halves separating. In fact, they'll not stay in place unless this is secure. Also linked to the ECU through connectors are a number of relays. Relays operate in the following manner. current is passed through the wire, producing a magnetic field in the windings. This draws a set of contacts together, allowing a heavy current to be drawn through them. Is the following statement true or false? When a current is passed through the solenoid, the switch above will close. That's right. It's true. This gives when a current is passed through the solenoid, relay, it closes the switch above it. Of the engine this gives a flow of power to the appropriate component of the engine management system. If we take out the trim panel, we can see the relays identified by name, the square being the color of their base connector and the dot being the color of the actual relay. The main relay feeds the ECU and injectors, whilst the pump relay feeds the fuel pump. So when the ignition is switched on, which relay will come into operation first? No, yes, the main relay comes into operation first. Has to be closed, then feeds the injectors, and the ECU has to switch in the pump relay, which then switches in the fuel pump. Also within the harness are two types of earth, logic earth and chassis earth. They're represented by these two symbols. If we disconnect the battery and remove it from its tray, we can see the location of one of these earth types close to the battery. Which of the two types of earth is shown here, logic or chassis earth? No, yes, logic earth. It must be placed within 9 inches of the battery, whilst the chassis earth can be placed anywhere on the car. Note also that it is the negative terminal from the battery which is linked to the logic earth. Now let's look at the signals from each of the components to the ECU, starting with the air mass meter. Where is this located? No, yes, that's right. The air mass meter is located between the air filter and throttle housing. By the air mass meter varying its voltage level, the ECU can calculate the temperature, volume, and density of air entering the engine. Next, the crankshaft sensor, which informs the ECU of engine speed. Which of these signals would represent a high engine speed and which would represent a low engine speed? A or B? Yes, that's right. The high engine speed signal would look like this, while the low engine speed signal would look like this. From this signal, the ECU can calculate precise engine speed. The crankshaft sensor is also used to calculate crankshaft position relative to piston top dead center. Would this statement be true or false? The crankshaft sensor can sense this through the signal from the missing crankshaft teeth. No, yes, that's right. Taking a look at the signal, there is a distinct change when the missing teeth pass the crankshaft sensor. There is a distinct signal. Note how the voltage first goes negative, and then goes negative, and then positive. This signal forms a direct link to the ignition drive of the 3.6 engine. Next, the coolant temperature sensor. This is a thermistor with a negative temperature coefficient. So what happens to the electrical resistance of the sensor as the temperature increases? Yes, a negative temperature coefficient means that an increase in temperature would result in a decrease in resistance, and vice versa. From this, the ECU can calculate precise engine temperature. The coolant temperature sensor, along with the air mass meter and crankshaft sensor, form the primary sensors to the ECU. However, there are secondary sensors which also input information, giving the ECU a complete picture of engine conditions. The throttle potentiometer works on the basis that movement of the accelerator causes the throttle shaft to rotate. So, what is the throttle potentiometer being used to measure? Yes, this in turn is sensed by the throttle potentiometer, the actual throttle which varies its output voltage to the ECU. Temperature and volume of airflow are measured by the air mass meter, whilst the road speed is taken as a signal to the instrument pack. We've already seen that the battery is linked into the engine management system. What's the normal battery voltage? Yes, the normal voltage is 12 volts. Although voltage can vary, so it's important that the ECU monitors the changes, since any change injector opening and closing times. For the same reason, the ignition supply is sensed by the ECU. Both the air conditioning compressor and gear selection impose a load on the engine when engaged. What effect would this have on the engine idle speed? No,
yes,
the increased load put on the engine by engaging the air conditioning to maintain idle drive would cause
the
a
engine idle
decrease
speed
in engine
would
idle
then
speed.
fall.
A signal to the ECU represents that the air conditioning clutch is engaged. In the same way, the linear gearbox switch inputs information to the ECU on gear lever position. From these sensors, the ECU can sense engine temperature, load, and speed. It then compares this information with its mapped memory and selects optimum settings. The ECU controls injector pulse adjustments and ignition drive, giving complete engine management. Let's take injector pulse adjustments first. Which of these sensors will inform the ECU of engine temperature? No,
Yes, that's right.
The coolant
The ECU
temperature
can
sensor
calculate
informs
precise
the
engine
ECU of precise
temperature
engine temperature
through the coolant
The
temperature
sensor
gauge.
is used to sense temperature within the car. No, the air mass meter informs the ECU of air temperature, volume and density, not of engine temperature. It is the coolant temperature sensor that does this. The ECU will immediately respond by opening the injectors for a longer period when temperatures are low, increasing the injector on time and giving cold start enrichment. In the same way, the ECU provides cranking enrichment irrespective of engine temperature. It does this in response to the crankshaft sensor input. What information does the crankshaft sensor give the ECU? No,
Yes, that's right.
The crankshaft gives the ECU information on engine speed and crankshaft position. During cranking enrichment, the ECU responds by opening the injectors 3 times per crankshaft revolution. Once the engine has started, normal injection occurs. How many injections per engine cycle would this be? Yes, that's
No,
right.
there are
Twice
2
per engine cycle. The ECU also provides after-start enrichment, irrespective of temperature, simply by increasing injector on time. Lastly, the ECU provides injector pulse adjustments during overrun conditions. When would this be? No,
Yes,
during
overrun
means that there are high engine speeds and a closed throttle. During overrun conditions, injector opening is suspended and the overrun valve within the idle speed controller housing comes into operation. During overrun, what will manifold pressure be?
Yes,
No, it
it'll
would be
be
high, since a massive depression would be created in the inlet manifold. This would draw open the overrun valve, filling the manifold with air, giving a good response when the throttle is opened. Now we come to ignition drive, an output from the ECU. In response to crankshaft position, ignition pulses are applied to the ignition amplifier. What does this control? Yes,
No,
the ignition amplifier controls the on-off switching of the high-tension injector from the coil is controlled by the ECU. The ECU will determine the dwell time of this and adjust coil energy accordingly. Having seen both fuel injection and ignition drive, let's examine other features of the engine management system. First, the idle speed controller, which consists of a plunger operated by a stepper motor. It only operates at idle in response to an increase or decrease in electrical or mechanical load on the engine. Why is the information received as a signal input direct to the ECU rather than first being sensed through the crankshaft sensor? No,
Yes,
although
the
driver
driver
would detect the change in idle speed if the signal were first input to the crankshaft sensor, to then be input to the ECU. So the direct signal to the ECU means that the idle speed controller compensates before the load is felt by allowing air into the inlet manifold. Next, the supplementary air valve. Would you agree with this statement? If engine temperature fell below -20 degrees centigrade, it would be sensed by the coolant temperature sensor. Yes,
No,
that's
it
right.
would be sensed
and
by
the
the
information
coolant
would be
temperature
input
sensor,
to the
and the information
ECU,
would be input
which
to
would
the
activate
ECU,
the supplementary
which
air
would
valve.
activate
the supplementary air valve. This would allow extra air to bypass the throttle butterfly, maintaining idle speed. The last output we'll look at from the ECU is its ability to detect faults within the engine management system. Once a fault is detected, it's displayed on the vehicle condition monitor, the VCM. At the same time, the ECU will return to its pre-programmed set conditions, allowing the car to remain drivable. This is its limp home facility. This completes our overview of the engine management system's operation. In this section, we'll be looking at some maintenance procedures for the engine management system. Both the throttle butterfly and the throttle linkage have service settings which can be followed. What control determines throttle position? Yes, that's right. The accelerator controls throttle position through the throttle linkage. After removing the elbow hose assembly from the air mass meter to the throttle housing, slacken this nut. What does it secure? That's right, it's securing the throttle cable to the manifold bracket. Now slacken the kick-down cable lock nuts to the manifold bracket, ensuring that both this and the throttle cable do not restrict the linkage adjustment. Now slacken the throttle stop lock nut. Having done this, the throttle stop screw must be adjusted to achieve a gap of 0.05 millimeters between the butterfly valve and the side of the throttle housing. What tool would be used to measure the adjustment of the gap? No, that's right, a feeler gauge must be used. To complete this procedure, tighten the throttle stop lock nut and recheck the butterfly valve setting. To set the throttle linkage, a special alignment tool must be used. But first, slacken this lock nut. But which one is it? No, yes, it is the full throttle stop lock nut, which, as its name suggests, governs full throttle position. Position the tool so that the pointer lines up with the idle mark I on the throttle linkage. Fully open the throttle. Check the position of the tool against the manual M or automatic A ridges. Adjust the full throttle stop so that the tool will line up to the correct ridge. Recheck the tool's alignment and tighten the full throttle stop lock nut. Remove the full throttle setting tool. Adjust the throttle and kick-down cables as specified in the workshop manual.